Hi and a very good day. So in this video session we will continue discussing about double exponential smoothing technique. Okay, so like my previous video, I already explained to you what are actually the main advantage of double exponential over single exponential. Okay, the major advantage is actually double exponential have an ability to generate multiple ahead forecasts. Right? Okay, so let's do some example by using the same data set. All right. Okay, so before that, uh, you need to understand that to forecast the value, we need basically four equations, right? Okay, so this is some simple calculation to estimate the value of all the equation needed to forecast the value, right? Okay, so before you can read this in the textbook. Suppose that the CPI value for the year, 9060 is 1.3. Okay, and then we will use alpha 0.6. Okay, alpha here is the smoothing constant. Okay, then uh we estimate the double exponential smoothing at 9061, or t equals to 2. Okay, so by using this example, alright, when you replacing the value, okay, now the initial value that we need is actually S60 here. Alright, okay, so we set up first. Okay, so this is Y. Okay, so this is ST S. Okay, for double exponential, and then AT BT. Right. Okay, and then Y hat. This is what we try to estimate. Okay, alright. So here, okay, based on the simple calculation, okay, so ST, and for the single and double exponential, we will use the same value as the actual value. Okay, for the initial value. Alright, and for Wahid also, we will start with the same value. Okay, so when we replace 80 here, okay, 80 for 9060, okay, as example here, okay, A60 is equals to 2ST minus S double T. So it means that, okay, when we replace the value of AT and BT, okay, betul ke? Hi and a very good day. So in this video session, I will continue discussing about double exponential smoothing technique, uh, which is under univariate modeling. Okay, so here, okay, again, like my previous part 1 video, the advantage of double exponential over single exponential is actually the ability of double exponential smoothing to generate multiple ahead forecast. Okay, so here the multi ahead forecast element of our double exponential is actually this as we can see here, for m equals to 1, okay, our at plus bt is times the bt times 1. Okay, for 2 step ahead, okay, at plus bt times 2 and so on. So the value will be not the same. Okay, so here some simple calculation manually obtained by use to estimate the value. Alright, so this is how we do it in the Excel. Okay, let's take a look at our data set here. We will use the same data set as the previous example. Okay, so let this be as our y, the actual value, and then we need st, and then for single exponential element, the double exponential, and then the at, bt, and also y hat, the estimated value, right? Okay, for this purpose of example, we start at t equals to 2, or this for this example use year, so we start at 1961 to estimate the value, right? But before that, as we can see here, you still need the initial value for st and s prime t. Okay, so what are the value? Okay, you can based on based on your reference, we say that the estimate value is equals to the actual value. So okay, 1.3 and 31.3. Okay, this is the initial value. Alright, so what is your initial value for at and bt? Okay, so here at and bt is actually, alright, okay, so at and bt is actually, okay, so since that our st is equals to 31.3, our s prime t is 31.3. Okay, so our at is 2 times 31.3 minus 31.3, so you will get the 31.3 ybt. Okay, alpha, the exponential smoothing constant that we use in this example is 0.6, so 0.6 over 0.4 times 31.3 minus 31.3, which is equals to 0, right? So that's why for this initial setup, okay, the value of our at is 31.3 and our bt is 0, and for our y hat, alright, y hat is the same as the actual value. Okay, so y hat 1 is actually equals to y1, so the value is 31.3. So after setting up the initial value, now you are ready, okay, you are ready to do double exponential smoothing. Okay, so okay, here I will just add another. Okay, so this is our forecast value. Okay, right, so okay, so let's begin. How can we do it? Right, okay, so now here st here is, okay, 0.6, okay, the alpha value. Okay, so to make sure that our alpha value can we can change our alpha value. Okay, sorry, I love to do like this because we can see the difference of alpha value will generate the different the different MSE. Okay, so I will refer our alpha value 0.6 here. So to do the modeling, right? ST, okay, S61 is equals to, okay, 0 point, okay, sorry, I refer to this cells, I lock it, okay, times, okay, Y61, the actual value of 61, okay, the actual value. So the actual value for 61 is this, right? Plus, okay, 1 minus, okay, this value, okay, times, okay, times, okay, S60, okay, the single exponential for 9060. So this is the cell, right? Make sure that you are putting the correct cells for each, okay, for each formula, right? So enter, and then we go for, okay, the double exponential element, right? S prime t, so 0 0.6, I refer to the cell and I lock it, okay, times S, okay, it's actually S61, okay, because before this, well, previously you use 61, so we will use 61, right? So this is the thing, this is, we refer to this cell, right? Plus, okay, 1 minus, okay, 0, sorry, 1 minus this cell, right? Okay, times, okay, times S prime 60. So the past observation of our double exponential smoothing. Okay, so this is the value. The next, A61, okay, equals to, okay, 2 times, okay, S, okay, minus this, right? Okay, and then BT, okay, BT is, okay, okay, to make sure that we don't, okay, I have to lock it because we want to drag after this 1 minus, okay, I hope you can follow, right? Times, okay, S, okay, S61 minus, okay, right, the single exponential equation minus the double equation, double smoothing equation, okay, and then click and, sorry, yes, alright, okay, make sure that you have okay, sometimes you have to be careful with this, right? Okay, and then y hat, okay, y hat is 80 plus 80 plus bt times, okay, for estimated purpose we use m equals to 1, so times 1, right? So this is our fitted value, right? And then you just drag up until all of our observation, drag and drag, okay, and drag and drag, alright, and drag, okay, stop here. Okay, so this is actually our 80, okay, you have to be very careful, this is your 80 and this is your bt, okay, because okay, this value we will use to generate the next forecast value, okay. So for m equals to 1, okay, suppose that this is m equals to 1, okay, for 1999 m equals to 2, okay, for 2000 m equals to 3. Okay, remember our forecast value. Okay, our forecast is, the formula is, okay, the formula is AT, right, plus BT. Okay, I lock here. No need, right? AT plus BT times 1 for one step ahead, right? For this is 2 step ahead, so AT plus BT times 2. This is your 2 step ahead, and then for 3 step ahead, AT plus BT times 3. Okay, so this is actually your forecasting for 1 step ahead, 2 step ahead, and 3 step ahead. So how do we measure actually which alpha should give you the best forecasting result? Okay, so here again, okay, we need to calculate the MSE, which is we need the error, and okay, error is equals to actual minus fitted. Okay, and then the square of error. Okay, so here the actual is this. Okay, so you perform the formula. This is your fitted, right? So just drag up to the observation, and then okay, this is square. Then right. Okay, so for MSE the formula is, okay, sum of, okay, sum of your square error here over, okay, over, okay, how many observation that you taking the sum for. Okay, so the observation is 38. Okay, over 38, right? And you get the MSE. What if we choose another value? Okay, 0.2 as example. So MSE for 0.2, if we use alpha 0.2, the value should be 3.85 MSE, and then the forecast value should be 111, 5681, and so on. Okay, so here for, okay, I will change back to 0.6. Okay, so this is the result for the forecast value. Okay, if you want to make it more tidy, you can always change the decimal places. And I think, alright, that's it. Okay, this is how you perform double exponential smoothing by using Excel. Okay, and you can check whether your result is the same as my example and textbook. And I think that's all for double exponential smoothing. If you have any question, you can always reply under the comment, or you can ask your respective lecturer during our online discussion. Okay, thank you guys for listening. See you.